Okay, so we are going to look at 7-4A, which is simplifying numbers with rational exponents. So our objective with this is just that. So we are going to simplify numbers that contain rational exponents. Okay, and all of this stuff can be found on page 382. So let's look at our first example, where I have 100 raised to the 1/2 power. So normally you can just type into your graphing calculator 100 caret 1/2 and find out your answer. However, sometimes it's not always going to be perfect. So let's talk about how we can apply this. So the big thing is, anytime you have a fraction in your exponent, the numerator is actually the exponent of the number. The denominator is actually the root for the number. So what I'm going to do here is I am going to have the square root, because 2 is my root, of 100 raised to the first power. Now 100 raised to the first power is just 100. And then what I would get is I would have this just the square root of 100, which we all know is 10. So at that point, that one's pretty simple. So anything raised to the 1/2 truly will just be the square root of that number. Let's look at something that's a little bit more difficult. Number 2, I have 32 raised to the 2/3 power. So again, remember that the 2 is the exponent of the number. The 3 is the root of the number. So what that means is I have the 3rd root of 32 squared. Now, in this case, I could look at this and say, oh, well, I need the calculator to do 32 squared and then to find the cube root of it. But let's actually break this down a little bit more if we didn't have a calculator, because what you're going to notice is you're not going to be able, it's going to end up being a decimal answer. So what do you do? So what I'm actually going to do is I have the cube root, and I'm going to write out, this is 32 times 32, because 32 squared is just 32 times 32. Well, now what I'm going to do is I'm going to do the prime factorization. So 32, I can do 8 and 4, I can do 4 and 2, I can do 2 and 2, I can do 2 and 2 here. So what I have here is I have 1, 2, 3, 4, 5 2's. So just from that 32, I have 5 2's. So from this 32, I know I'm going to have 5 2's. I don't need to redo what I just did here. I figured it out, so then I'm just going to list what I've got. So because it's a cube root, I need them in groups of 3. So here's one group of 3, here's another group of 3, and there's another group of 3. Okay? So now what I have is I have 2 times 2 times 2, which is 8. Okay, it's not 2, 4, 6. It's 2 times 2 times 2, which is 8. And then I've got the cube root of my leftover, that lonely old 2. So then that would end up being my final answer. So even if you did not actually have a calculator for this, you can certainly figure it out using all of your skills. So let's move on to yet another problem. Number 3. I have 4 to the 1/4 power times 64 to the 1/4 power. Okay, so again, remember the numerator is the exponent, the denominator is your root. So what I have is I have the 4th root of 4 times the 4th root of 64. Okay, so because they're the same root, I know that I can just multiply those numbers together. But I'm not actually going to fully multiply. I'm just going to do 4 times 64, similar to what I did in the previous one that I just wrote out 32 times 32. So now I'm just going to do the prime factorization. So 4 can break up in, oops, why did I just write a 4? 4 can break up into 2 and 2. Now 64, it's not the same as 4, so I actually do need to do the prime factorization. So I can do 8 and 8. Here I can do 4 and 2, and 2 and 2. Here I can do 4 and 2, and then 2 and 2 again. So because it's a fourth root, I need them in a group of 4. So there's one group of 4, and then I have 1, 2, 3, 4. So that is another group of 4. So I can do 2 times 2, which is 4, and there are no leftovers. So therefore, my final answer is 4. Okay, so far so good, hopefully. Hopefully this seems pretty easy for you. So now let's look at number 4, where I have 243 raised to the 1.2 power. Okay, so this is a decimal, it's not a fraction. We only have seen stuff with fractions. What are we doing? What's going on? But it's really not a big deal. Let's use our skills. We would read this 1.2 correctly by saying 1 and 2/10. So I'm going to write 1 and 2/10. So I can write it as a fraction. I'm going to go ahead and reduce that. So I get 1 and 1/5, because if I divide the 2 and the 10 by 2, I get 1/5. And now let me write this as an improper fraction. So 1 times 5 is 5, plus 1 is 6. So actually 1 and 1/5 is 6/5. So now let's rewrite this as 243 raised to the 6/5 power. Okay, so again, the denominator is my root of 5, and my numerator is the exponent for my for that base, for that 243. So right now this can seem incredibly crazy, because that means 243 I should write 6 times. And you're right. You should write it 6 times. So this is going to be 5th root of 243 times 243 times 243 times 243. I'm going to run out of room because I only have 4 times 243 times 243. Okay, so I'm actually going to go ahead and use the next page just to show what we have to do for this. So if I have, so again, I've got the 5th root of 243 times 243 times 243 times 243 times 243, and I need one more, times 243. So I've got 6 of them, 1, 2, 3, 4, 5, and 6. So what I'm going to do is I'm going to break down one of the 243s. Okay, so here I'm going to use my divisibility rules. 2 plus 4 is 6, plus 3 is 9, so I know 9 can go into it. It's actually going to be 9 times 27. The 9 I can break down into 3 and 3. The 27 I can break down into 9 and 3. And then the 9 I can break down into 3 and 3. So what I have here is I have 1, 2, 3, 4, 5 threes. So this one gets 5 threes. 1, 2, 3, 4, 5. This one gets 5 threes. 1, 2, 3, 4, 5. This one gets 5 threes. 1, 2, 3, 4, and 5. This one too. 1, 2, 3, 4, 5. And that one too. 1, 2, 3, 4, 5. Okay, so we know what each prime factorization is because they're all the same number. And I have to put them into groups of 5. Well, isn't that just perfect? I've got a group of 5 there, a group of 5 there. This one ended up being nice and easy for us there because they're all already grouped. So now what I have to do is 3 times 3 times 3 times 3 times 3 times 3. So I'm going to have to multiply 3. So basically, it's going to be 3 to the 6th power. And that you can calculate in your calculator, or you could actually just break it down like 9 times 9 times 9, and you get 729 for that. Okay? So the big thing is to break it up and to make sure that that you're doing that prime factorization, that you're grouping properly, because this one came out nice and pretty. But sometimes we do have some of those leftovers, like what we saw in number 2. Okay, and so we've got this leftover. So if you just utilize your calculator and just calculate it, you might get a decimal. But I don't want any decimal answers. I want to know truly what it is. So it's very important to follow that protocol. So then I have a couple more problems for us to look at.